Hello everyone. In this video, I'm going to discuss the Cambridge International AS and A-Level paper 1-3, May-June 2023 paper. So in this video, I'll be discussing the first 10 questions of this paper. The first question is, what must be included in a record of a physical quantity? So we know that the physical quantities have a numerical value and a unit. But the thing is, for a physical quantity to be recorded, the unit is not necessary. If you are taking the case of a strain, in the case of refractive index, in the case of number of oscillations, these quantities doesn't have any units. So the must thing won't be containing a unit, an SI unit and a unit expressed in base unit. So option B and C is not a correct option. So it could be either A or C. An integer value for the quantity, a numerical value for the quantity. So what's the difference between these two? Numerical values can be integers, decimals, fractions, or even irrational numbers, right? So if you're recording a value, it could be anything. It could be an integer, fractional, or decimal, anything, right? But if you are considering the option A, an integer, it's just a specific type of numerical value. So which must be included in a recording of physical quantity. Of course, the option C is the correct answer for this question. Question number 2. What is the ohm expressed in SI base unit? We know that the ohm is the unit of resistance, right? So in the case of units, we need to consider the basic equation for that quantity. So you can use the Ohm's law, which will give you the R value as V over I. Right, so V stands for the voltage. So voltage is basically the work done over charge. So what is the work done or energy transfer per charge is considered as the voltage or the potential difference. So you can just break down this expression like work done is force multiplied by distance then divided by charge. Force is mass times acceleration, right? So this would be the basic equation for voltage. So using this equation, you can find out the basic SI base unit for voltage by considering the unit of these quantities. So mass is kilogram, acceleration is meter per second square, and this is the distance, which is also measured in meter, divided by the unit of charge. We know that these are the basic units. So here the electric current is having a basic unit of ampere, but here in this equation it is charge given, which means that you need to consider the basic equation for current, which is charge over time. So you can rearrange, you'll be getting charge is equal to current multiplied by time. So the unit, the basic unit of the charge would be the unit of this current, which is amperes, multiplied by seconds. So here it would be amperes second, which is kilogram meter square s to the power of -3 amperes inverse. So this is the basic unit for voltage. So you can find out the base unit for the resistance, which is ohm, which is equal to kilogram meter square s to the power of -3 a raised to -1 divided by the unit of current, which is amperes. Here you are getting the answer like this. So which one is the correct answer? So correct option would be option A. Then the third question. A desk has a true width of 50 centimeter. Two students X and Y measure the width of the desk. Student X uses a tape measure and records a width of 49.5 plus or minus 0.5 centimeter. Student Y uses a meter ruler and records a width of 51.4 plus or minus 0.1 centimeter. Which statement about the measurement of student X is correct? So here the options are given in accuracy term and the precise term. So you need to understand what is the meaning of accuracy and precision. A precise reading is one in which there is a very little spread about the mean value. So suppose you have taken like a 5 number of measurements for the same quantity. So if these measurements are spread across each like in a far distance, then it is not precise. If it is like it is having a very little spreading, then it is having high precision. Let's take this picture. Okay, so here the true value is here, the center of the circle. These crosses are representing the measurements that you have taken. So here it is 5 measurements given, right? So the 4 figures are having these 5 measurements, but it is spread in different way. Okay, so in this first figure, these measurements are widely spread, so it's having low precision. But check the next picture. So here the measurements are like really less spread, right? The spreading is very little, so it's having high precision. So here is also less spreaded, so it is having high precision. It's widely spread, low precision. So this is how the precision is varying, right? So then, what is meant by accuracy? A measurement is described as accurate if the value obtained is close to the true value. Yes, we have the true value and we need to find out which one is really close to this value, right? So these measurements are really close to this true value. I told you this is the true value. Okay, so the measurements are really spread like near to this true value, so it's having high accuracy. But here this is the true value position, but the measurements are in the other direction, not close to the true value, so it's having low accuracy. That's how the accuracy is determined. Okay, so here it is, the student X measurement is 49.5. Okay, the true value is 50. So how much is the difference? Just 0.5. But just check the next one. If this one is having more accuracy, then student X measurement is less accurate. Okay, so you need to consider student Y measurement also. Here it is 51.4 and the true value is 50, which means that it's having a difference of 1.4. So which one is really close to the true value? Student X. So the student X measurement would be more accurate, right? So it is more accurate. So out of these 4 options, it would be either C and or D would be the correct answer. Then let's check on this precision. Okay, so here the value measured would be around this precision, right? So 49.5 plus 0.5, how much it would be? 50, right? So 49.5 minus 0.5, it could be 49. Okay, so the difference between the measurements, okay, would be 1. So the measurements are at a distance of 1. It's widely spread, you could say. Let's check the measurement of student Y. It would be 51.4 plus 0.1, which means that 51.5. Then the other measurement would be 51.4 minus 0.1, which is 51.3. So the difference between these two is just 0.2. So these two values are really close to each other, right? So comparatively, student Y measurement is having more precision, so student X measurement is having less the precision, right? So which one is the correct answer? So out of these 4 options, option D is the correct answer. Then the next question, question number 4. The diagram shows 2 vectors X and Y drawn to scale. Okay, so X and Y. If X is equal to Y minus Z, which diagram represents the vector Z? Okay, you need to find out which is the C vector, right? So let's check this equation, x is equal to y minus z. So please rearrange this equation in order to find out z. So z is equal to y minus x. So how to subtract two vectors? So you can subtract two vectors, or you can add the negative of one vector like this, plus minus z. So if you are considering the negative of x and you are adding with y, you will be getting the c vector, right? So how to find out the negative? In the case of vectors, if you want to find out the negative of it, it would be of the same magnitude but in the opposite direction. So the x vector would be having the direction opposite to the previous one. So this one would be representing minus x. So you can use the triangular method. So and move to this vector. I'm just adding the head to the tail of this y, and this would be the minus x vector or negative x vector. So I am just joining the tail to the head of the second vector. So this vector would be representing the z vector because this one is minus x. So which one is close to this vector? Option A. So option A is the correct answer for this. Question number 5. Which equation representing uniformly accelerated motion in a straight line can be determined using only the definition of acceleration? So these equations are equations of motion, and you need to find out which one is considering only the definition for acceleration. So let's consider the definition of acceleration first. Acceleration is the rate of change of velocity, right? So let's consider it is moving with it's a uniformly accelerated, right? The initial velocity is considered as u and the final velocity as v, and the journey is in the time t. Then this equation would be varying like this: final velocity minus initial velocity divided by the time taken. Please do rearrange. You will be getting at is equal to v minus u, or v is equal to u plus at. This is option C. So in order to find out this equation, you just need to consider the definition of acceleration. So option C is the correct answer. Question number 6. An object moves from rest with uniform velocity horizontally and uniform acceleration vertically. Which graph shows the variation with time of the displacement of the object from its initial position is right? So the initial position here is rest. So rest, which means that the displacement is you can take as 0. All the graphs are showing the same, so it doesn't matter. Let's check the first one, the horizontal case. So it's having a uniform velocity horizontally. So velocity in the horizontal direction is the same, but it's having a vertical acceleration, right? So this is a case for the projectile motion, right? So how the graph would be varying? Displacement time graph. If it's having the uniform velocity, the displacement time graph would be a straight line passing through the center. But if you are considering option A and option C, which is considering the horizontal displacement, none of them is having a straight line. Both are curved, which means that these two options are wrong. So let's consider the next option, uniform acceleration vertically. So here B and D options are showing the vertical displacement. How the vertical displacement is shown will be varying for a uniform acceleration. It would be like a curve. So it would be curved upwards. Okay, the reason is that in the case of uniform acceleration, obviously the equation of motion will be obeyed, right? So S is equal to ut plus half at square, which is one of the equations of motion. So this one should be obeyed, right? So initial velocity is 0 since the object moves from rest. S would be equal to only half a t square. So here this S stands for the displacement and t is the time. So A which is a constant here. It is uniformly accelerating, which means that s is proportional to t square because half and a are constants. So the quantity on the y is proportional to the square of the quantity on x, so the graph is obviously would be a parabola. Okay, and since the acceleration, it's an acceleration, it would be curved upward. If it's a deceleration, it would be curved downward. So this one is representing the uniform deceleration, and option D is representing the uniform acceleration. So option D is the correct option. Question number 7. A device for spraying paint consists of a box with its faces horizontal and vertical. One of its vertical faces contains small holes. Paint is fed into the box under pressure via a vertical tube and exits through the holes as fine streams moving horizontally. The paint is ejected at a speed of 2.5 meter per second through 400 holes, each of area 0.4 millimeter square. The density of the paint is 900 kilogram per meter cube. What is the horizontal force required to hold the device stationary as it ejects the paint? So these are the holes, right? So if the paint is spreaded outward, there will be an equivalent force on the opposite direction in order to hold the device stationary. You need to find out what will be this horizontal force. So how to find out that? You can use the Newton's second law of motion. By that, the formula for the force is the rate of change of momentum. You know the momentum P is equal to mass times velocity, right? So here it would be mass times velocity divided by the time taken. But this force is not only from one hole, but it would be from 400 holes. So you need to consider the 400 multiplied by NV over t case. But we have the velocity, but we don't have the time and the mass. So you need to consider the density equation, which is mass over volume. So using the density formula, the mass equation can be written like this: rho multiplied by V. So the here V stands for the volume. So F would be equal to 400 multiplied by rho V multiplied by V divided by T. Let's consider the volume. So volume would be area multiplied by the length, right? So volume is equal to area multiplied by length. So the area is given. Area for each hole is given, but we don't have the length, right? So we can substitute this equation here. So it would be area multiplied by the length multiplied by the velocity divided by time. So here the length is divided by the time. So let's consider the L over T as the velocity. So the formula would be like this: 400 times rho times A times V multiplied by V, which is V square. So this is the formula that you need to use. So 400 multiplied by the density is 900 multiplied by the area, which is 0.4. It is millimeter square. So you need to convert into meter square. So 1 millimeter is 10 to the power minus 3 meter. So 1 millimeter square would be 10 to the power minus 3 square, which is 10 to the power minus 6 meter square, multiplied by velocity 2.5 square, which is equal to 0.9 Newton. So option B would be the correct answer. Question number 8. Each diagram illustrates a pair of forces of equal magnitude. Which diagram gives an example of a pair of forces that is described by Newton's law of motion? So for the two forces to make up Newton's third law of pair, it must be following the following characteristics. So the first one is they act on different objects. Let's consider the first case. No, the forces, the total resistive forces and the driving forces, both are acting on the same object, the car. Option C, the same box. Option D, the forces are from the same, acting on the same aeroplane, right? But if you're considering option B, these two forces are acting on different object. Force from earth to moon and from moon to earth. So which one is the correct answer? Option B. Question number 9. Two balls of identical shape and size but different masses are falling through the same liquid. The sum of the drag force and upthrust acting on each ball is equal to its weight. Which statement about the two balls is correct? So the first two options are showing that it's having the heavier ball is having larger acceleration, the heavier ball is having smaller deceleration. So let's consider, is there any acceleration or deceleration in this case? Okay, so let's consider the liquid. So here it is, the liquid. When there is a ball falling on this liquid, the weight would be downward. There will be always an upthrust and there will be a drag force in the opposite direction of movement. Since it is falling, the drag force will be upward, right? So if the forces on this ball are balanced, which means that the sum of upward forces is equal to the sum of downward forces, then we could say that the ball is falling on the same speed, right? Which means W is equal to Fd plus upthrust. If this ball is satisfying this equation, it doesn't have any acceleration. The velocity would be constant, right? So here it is given that the two balls are satisfying the equation in the question itself, which means that it doesn't have any acceleration or deceleration. So option A and B are wrong options. Then let's check the other two options. The heavier ball is falling at the same speed, or it is moving at the larger speed than the lighter one. Since we know that the balls are having different masses, let's consider the masses of the two objects like this, okay, M1 and M2. So here let's check what is the upthrust value. You know that the upthrust equation is rho Vg. Since the two balls is having the same shape and size, the V value, the volume would be the same, and it's falling on the same liquid, so the density also be the same, which means that the upthrust for both the balls would be the same. But the weight and the drag force is not. The weight is mass times g, so it depends upon the mass of the object. So obviously the heavier ball would be having heavy weight, right? Then the drag force, which is having an equation of 6 pi eta rv, the drag force is directly proportional to the speed. If the speed is more, the drag force also be more, right? So let's consider the two masses. Out of these two masses, the M2 mass is having the more mass comparing to mass 1, M1, okay? So W2 is greater than W1. So in this equation, this upthrust is a constant. So if the weight is more, the drag force also be more, right? So the second mass is having the heavier mass is having more weight, so it's having larger speed, which means that it cannot be falling on the same speed, but it's having a larger speed. So option D is the correct answer. Question number 10. A perfectly elastic collision occurs between two objects X and Y. The mass of X is m and mass of Y is 4m. Object X travels at a speed v before collision and speed 3v over 5 in the opposite direction after the collision. Object Y is stationary before the collision. What is the kinetic energy of Y after the collision. So kinetic energy formula is half mv square. So the m value for this object y is 4m, so half 4mv square, but we don't have the velocity for this object y after the collision. So you need to first find out this v value. So which formula that you could use? You can use the momentum conservation here, since the collision is a perfect elastic collision. So the momentum conservation is the sum of momentum before collision would be equal to the sum of momenta after collision. So before collision, let's consider the speed for the object 1 is u1 and for object 2 is u2, and after collision v1 and v2. So here the u1 is v for x. Here, since the object y was stationary, it is 0. Here this v1 is 3v over 5, and v2 let's consider as v2 itself. Okay, so the sum of momenta before collision, momenta is mass times velocity. So here it's having only the momenta for the object x, which is mv, which is equal to the momenta after collision. Since the object is moving in the opposite direction, let's consider this one as negative. So the movement to the right side is considered as positive, so to the left would be negative. So minus m 3v over 5 plus 4m, the mass and the velocity. Okay, so 4mv2 would be equal to mv plus 3mv over 5. So let's take the common mv outside, and it would be 1 plus 3 by 5, which is equal to mv 8 over 5. So mv2 would be equal to mv 8 divided by 5 times 4, m and m get cancelled. So v2 would be 8 divided by 20v. So this would be the velocity equation. So the kinetic energy is half times 4 times m times 8 divided by 20v whole square. So let's do this calculation, and you'll be getting 256 divided by 800 mv square, which is equal to 16 over 50 mv square, which means that option C is the correct answer. Hereby we discussed the first 10 questions of this paper. Let's discuss the other questions in the next video. Bye.